Hello everybody, so today I will talk about calculus. The topic today is about integration. So now I will show you the technique. For the first one, we need to put about x minus 1 to the power of 2, and we have number 4 in here. And here we have x dx. So in this situation, we can use about trigonometric substitution. So we put about x minus 1 equal to 2 tan t. So we do first derivative in the both sides. You got about 2 secant of t squared dt. So about s, we need to put negative number 1 go to the right, and you got about 1 plus 2 tan t. Ds, we change for this one. So about the square root, we have s minus 1 in here. We change for 2 tan t to the power of 2 plus 4. Now we need to simplify. The square root of number 4, you got about number 2. And this one, we change for secant of t squared. The square root of secant of t squared, you got about 2 secant of t. We simplify 2 secant of t in here, and you got about 1 plus 2 tan t secant of t dt, and we got about secant of t 2 tan t secant of t everything dt. The integral of secant of t, you got about ln the absolute value of secant of t plus tan t and the next one, you got about 2 secant of t plus c. About t in here, we need to change back for, we divide both sides with number 2, and we got about t equal to arc tan s minus 1 over 2. So we put this one go in here, and we got about ln the absolute value secant of this one, we put in here, and we have tan with r tan, you got about s minus 1 over 2, and we have 2 secant of tan in here, and we put about c is about constant, and this is the final answer. Now let's go to the next one. So for this one in here, we have the square root, and in this situation we can change into negative s minus number 3 or positive number 3, and you got about positive number 24, because if we expand this one, you got about s squared plus 6s plus 9. We have negative number 9 plus 24. That's why you got about number 15 in here. And now we use about trigonometric substitution. So in this situation, you got about s plus 3 equal to the square root of number 24 sine t. So you got about the s equal to the square root of number 24 cosine t dt. So we put everything in here. So we put this one go in here. So you got about 24 sine t square plus 24. So we put the square root of number 24 outside. About this one, you got about cosine t square, and this one we cancel. So you got about the integral of number 3 dt. We got about 3t plus c. About t, that's about this one. We divide both sides with the square root of number 24, and we got about t equal to r sine s plus 3 over the square root of number 24. So we put this one go in here. And this is the final answer. So we go to the next one. We will do about the s over the square root s squared plus 2s plus 1 minus 1. So you got about the integral s plus 1 everything to the power of 2 minus 1. So we can use about trigonometric substitution. So we got about s plus 1 equal to secant of t. ds we got about secant of t tan t dt. This one we change for tan t square, so we have the square root, so you got about tan t. So we got about the integral of secant of t dt, and now we got about ln, the absolute value of secant of t plus tan t. About t in here, we need to change into t equal to arc secant. So you got about ln secant of arc secant s plus 1 and we have tan t with this one. Let's see about arc secant. Secant with arc secant, you got about s plus 1. So we go to the next one. So for this situation, we can put about s plus 1 to the power of 2. So this one we put about tan t ds equal to secant of t square. So we put number 1 go to the right, and we got about tan t minus 1 ds we change for secant of t square dt. This one we change for tan t square plus 1. So this one we change for secant of t square, so we divide with secant of t in here. Oh, this one I made a mistake. This one should be about number 2. So we got about s plus 2 equal to tan t. So you got about the s equal to secant of t square. So we put number 2 go to the right. We have secant of t square dt. So this one we change for secant of t square, simplify with secant of t in here. About t, we use about r times of s plus 2. That's the end. Thank you for watching.